One of the most exciting and useful functions in Java is inheritance. Inheritance allows creating the hierarchy of classes having the parent class, which is called Superclass in Java, and the derived class, which is called Subclass in Java. Inheritance is a very common thing in the real life. Think of the cat family. All of its members have a lot of common features: fur, tail, whiskers, you name it. I am nothing of a biologist, but obviously, all Felidae look very similar to each other. They share common methods. All of them hunt, eat, and run. And still, a cat and a lion have a lot of differences. So here, the Felidae is a superclass, whereas the cat and the lion are derived from it, and are its subclasses. Both cats and lions have all the features of the Felidae and all the methods of the superclass, but they can be implemented differently. Let's present this all in the code. Launch idea. Create a new project. Call it inheritance. Add a new class main. And create a program entry point. Now create a new class, cat family, the Felidae. All fields, let them be public for now. Public int ears, the number of ears. Public int legs, the number of legs. And a Boolean variable which will store information if this animal has big claws. Call it big claws. Let's create a constructor without parameters and assign it default values. A typical field has 2 ears, 4 legs, and big claws. Now let's create another class called cat. It will be derived from the cat family. Call this class cat. To show that this class is derived, use the keyword extends. Then write the class which it is derived from. It's cat's family. Type cat family. Let's create a constructor of cat class without parameters. There are no fields, but because it's a subclass of the cat family, it has all the fields of its superclass. Let's just specify that there are no big claws. Assign false to the big claws variable. It doesn't matter that this field in cat class has not been declared. It's inherited from the cat family class, so we'll address it directly. Now let's create class lion. It will be also derived from cat family class, the Felidae. It will not have any specific features. It has 4 legs, 2 ears, and big claws. Now go to method main and create 1 cat and 1 lion. As you remember, we have not assigned any values to the fields. Let's display how many legs it has. Type sout lion.legs. Run the class and you can see that the lion has 4 legs, although we have not assigned any values or declared any fields in this class. It inherited them from its superclass. Now let's print out whether the cat has big claws. We will pass cat.bigclaws to systemout.println. Run the program and we can see false. The cat has no big claws. Why? It was declared in the superclass that all the Thelidae have big claws. Our cat has inherited this field, but since the cats have no big claws, we have assigned this field its own value in the cat class. The cat is a field, but it has its own specific features. Now let's create a method which will display the information about an animal. Declare it in the superclass. Let this method be public. It will be void because it returns nothing. It will print out information on the console. Call it showInfo. This method will display the line, the number of ears, the number of legs, the number of claws. Go to method main and call showInfo method from both animals. Run the program and you can see the cat has 2 ears, 4 legs, and no big claws. The lion has 2 ears and 4 legs too, but it has big claws. This method uses the value of the variables of exactly the animal from which it was called. Now it has unlimited access to the fields. It's a breakdown of encapsulation. Let's apply access modifier private to the fields. Now let's go to class cat, and you can see we have an error. Access to the restricted fields is not granted, even though this class is derived from the cat family class. The code has these fields, but not an access to them. One of the ways to grant access is to create a setter. Add the setter in the superclass. Use the Alt plus Insert keyboard shortcut for that. Select setter and select setter for big claws. Go to class cat, and in our constructor call method setBigClaws and pass it false as a value. Since we are inside the class cat, which is derived from cat family, we do not have to refer to any specific object. We can simply call methods which are defined as public and set them their values. Now we can run the program and see that everything works just like it worked before. The same can be accomplished using a constructor. Let's declare a parameterized constructor and initialize all the fields. Now go to the class cat and call the constructor of the class cat family. To call a superclass constructor, use the keyword super. Let's delete this method. Write super and pass it as an argument to ears, 4 legs, and false, meaning that the animal has no big claws, so it's not a problem. The class lion works just fine. Run class main. Everything is fine here too. Now let's delete the constructor without parameters. Now in the class cat family, there's only one constructor with parameters. Go to the class cat, no errors so far. Go to the class lion, and here is an error. Why has that occurred? It's because when we created an object of a subclass, the superclass constructor without parameters is called silently. Let me show where this is happening. Get the constructor we have deleted back here. You can see what happens when we create objects. Go to the class lion. Let's create a constructor without parameters in this class. You can see what happens when we create subclass objects. You can remember that unless we have added a constructor, it's created automatically. Firstly, a superclass object must be created in the constructor. Thus, its constructor is called super and constructor without parameters. That is, unless we have manually created a constructor, this constructor is created automatically. A constructor without parameters in which the superclass constructor also without parameters is called. Once we have deleted the constructor without parameters from the superclass, but there is still a parameterized constructor within it, it means that the default constructor without parameters is not created here anymore. So in the class lion, we cannot call this constructor because it does not exist. Now there's only a parameterized constructor there, so let's call it. A lion has 2 ears, 4 legs, and big claws. Now the ear is gone. This is a rule to remember. If the superclass features a parameterized constructor and has no constructor without parameters, the existing constructor must be called from any subclass in the first place. Here they are lion and cat, and all the required parameters must be passed to it. And there was no error in class cat exactly because we, in the first place, called the superclass constructor. Let's now define method eat in the superclass. Let it return the line eating the food. Write public string eat. It will return eating the food. Let's not return the line, but rather print it out in the console. Call this method from both of our animals. Run the program. Both animals are eating the food, but cats and lions eat different food. So it would be great if calling this method from the cat returned the string eating whiskas, and from the lion eating an antelope. To do so, we can override this method, open the class cat, and create the same method. Public void eat. And let it print out on the console, eating whiskas. Run the program and see that the cat is eating whiskas, and the lion is still eating just the food. What we have just done is called overriding the superclass method. We took a method from the superclass and ordered it to do something else. Print out a different line. Every time a method is overridden, it's recommended to mark it with an annotation override. Do not be afraid of these horrible words. This is how it's spelled, override. This word does nothing, but it helps those people who will read your code understand that it's not just another new method, but an overridden method of the superclass. This annotation is also needed not to confuse names. For example, you have written eats and encountered an error because this method does not override anything. Without the annotation, we would run the program with an error and would not understand immediately why our method is not defined, and the cat still eats whiskas and not the food. Due to this situation, we can see the error immediately. Let's now override this method in the class lion. It's very easy to do by using the keyword shortcut Ctrl+O. Press it and select the method to be overridden. We need the method eat. Click OK. We will remove super eat for now, and I will explain later why. Let's print out the line. Eating an antelope. Run the program. Well done. Now the cat is eating whiskas while the lion is eating an antelope. Let's now change the code a little. Let the superclass method return the word eating, and the overridden method will display the type of a product they are eating. It'll be whiskas. And for the lion, it'll be an antelope. Run the code, and you can see only the words viscous and antelope displayed. The word eating is not printed out because we have overridden the methods. But what if we want the superclass method to be called the way it was defined? It's exactly when we need the keyword super, then dot operator and the method to be called. Let's do this. If we want to call the superclass method first, write super.eat. This will call the superclass method the way it was defined. Here it is the word eating. And then our line systemoutprintln will be called. Similarly, it can do this in the class lion. Write super.eat. Run the program, eating viscous, eating an antelope. Thus the method is called. It's from its chosen depending on the object. According to this method, first the superclass method is called and then some other action is performed. So it's more than enough information for today, I think. Here is the homework assignment. Since the topic is quite difficult, it might not be clear at first how to do it. Take your time, think, try to complete the task on your own. I will show you how it's solved. If you come to a standstill, watch my solution. Then remove the whole code and reproduce it by yourself. So the task is as follows. We already have the class box. We created it in our previous lessons. Create a new class boxWeight, which stands for a weight box. It's derived from class box. This box will have the same methods and fields as the superclass, and also an additional field weight. Create all the required constructors and getters and setters for weight. In the superclass, create a method called showInfo, which displays the information about the box, length, width, height, and volume. And in the subclass, this method must be overridden to display the information about the weight of the box. Then create two boxes in the method main, a regular box and a weight box. Assign them sizes using different constructors and print out the information. I will allow several seconds for you to pause the playback. Good luck! So let's proceed. Open our project. In the package box, create a new class, boxWeight, a weight box. It's derived from the box, so write extends box. Create a field weight of the double type. Like all other fields, this one is private. Add several constructors, the same as in the superclass. But here they will have an additional variable, weight. The first constructor, let's check which ones we have. We'll assign the value of 0 to all the variables of the constructor without parameters. Let's call the superclass constructor without parameters to have all the variables equal to 0. Variable weight will be also assigned the value of 0. So that's the first constructor. And now the constructor in which we pass all the parameters. Let's see in which order they are to be presented: width, height, length, and the additional parameter weight. I have made a mistake here. This must be width. First of all, we must call the superclass constructor to which width, height, and length will be passed. Here is the menu item which allows passing all these parameters at once. And to our instance variable weight, we will assign the value which we passed in the parameter weight. we will pass size to the following constructor. We are setting the values of all the fields as equal to size. Let's call the same constructor, but pass it the weight as well. Write public box weight. The first parameter is double size. The second one is double weight. And now we will call the superclass constructor passing it the variable size. Assign the value of the argument to this weight. So we have created this constructor, the constructor with one parameter and also the constructor without parameters. We cannot create the constructor to which we will pass box as a parameter, because a regular box has no weight. We cannot convert it into a weight box. Now in the superclass method, let's specify the method showInfo. Let it be public void, and we will call in showInfo. This method will print out this information: width, length, and height. We will override this method in the class boxWeight. Press Ctrl+O, select the method showInfo. First of all, we will call the superclass constructor. It's done by default here. Add one more line, weight. And let's pass the variable weight. Now we can create boxes in method main. Create a regular box. Pass it one parameter. Create a weight box. And pass it all the parameters: width, height, length, and weight. Now call the method showInfo from our boxes, from the first box and from the second one. Run the program. Everything works fine. The information about the first box is displayed, and the information about the second box is also displayed, and it's more detailed, and it has the field weight. As I have said before, if something is not clear, watch the video once again. Don't be afraid of erasing and rewriting the code several times. Nobody makes you rush. Take your time to understand. The better you understand the basics, the more confident you will be later. On the contrary, if you have not understood a topic completely, proceeding to the next topic will make things even less clear. And getting to the third topic will get you so confused that you would rather quit doing this all and get a job of a sales manager. Of course, you will not make this mistake. You will not quit programming. But do not move to a new topic until the current one is clear. See you later.